Hello and welcome to the first episode of the Breadboard Apprentice, a series where I document myself learning electronics through different projects. And the first project that I want to embark on is the creation of a 8-bit CPU, not unlike the CPU that Ben Eater developed in one of his projects. So why start with an 8-bit CPU as the first project? Well, it is sufficiently large in scope as a project, where I can extensively learn different concepts, both in electronics and computing, or computer architecture design. And also, in today's world, we are living with increasing number of abstractions in everything. And so with personal project like this, it's nice to cut through all of the abstractions and really get to understand how things works, and in this case how a CPU actually works. So let's have a look at what I tried to accomplish in this project. So let's go over some lists of requirements for this project, or some goals that I have set for this 8-bit computer project. So as I mentioned, this is gonna be an 8-bit computer, meaning that we have an 8-bit ALU that can do 8-bit computations. Where it differs slightly from Ben Eater's build is that I would really like to have a 16-bit address space so that we can address all the way up to 64 kilobytes of memory. I want the overall design to be modular in nature so that we can build each separate module of the CPU in sequence. And I know I may name this series the Breadboard Apprentice, but I would really like to be able to transfer this project into something more persistent than breadboards. Breadboards are great for development, as I have found out, but they are not all that reliable when you are trying to store or keep a project. And finally, as the requirement, I want some basic input and output. So in Ben Eater's case, the output was made from 7 hex displays. This I feel is sufficiently for the requirements, along with the LEDs displaying what the different register and what the buses are doing. For input, I would really like, or I really like the design of, or the design feel of the first Altair computer kit. So I would really like to be able to have some nice switches to program this computer at the first step. Then we go to some nice features to have, and this will be something that we do if everything works out for the computer. I would like to be able to display some simple VGA signal, some low resolution VGA signal. That way we can actually have a monitor to display. And that also means that we need some way to have a character set that we can display. Then I would really like to go along with this VGA output some keyboard inputs. And what are we actually trying to achieve to do with this computer? It would be really fun if we could go all the way to actually have some simple basic interpreter running on the computer at that stage. And if we actually manage to get a basic interpreter running, then maybe we can also program some games to run on the computer. And that is, I think, what I would like to achieve, all that I would like to achieve with this computer build. And so with the requirements for this, or the objectives for this project established, let's have our first look at the computer architecture that I have envisioned for this project. So as we can see here, I am gonna have 8 different modules. So from the protein counter, a stack pointer module, memory address register with the memory, then a instruction registry, flag registry, and control logic unit. I will have some A register, so that's general purpose register, the A module of which, then some ALU, and we will also have a B register module, and then finally some IO. And all of these modules will be connected through 3 different buses. So we will have a data bus, that's the 8-bit data lines going, then we will hook some of them up to a address bus, a dedicated address bus, which is 16-bit wide, and then we will also have some control lines going on a separate bus. And as I have drawn it here, the connections, so pretty much all of the modules will be controlled through or be hooked up to the control bus in some capacitor, and only the control logic unit will actually output to the control bus, and all the other units will input from the control bus. Maybe the I/O will also end up outputting to some signals to the control bus, but that is way in the future. So for the first module, the program counter, that will be connected to the address bus, of course, because it's pointing to an address space, or it's an address pointer to point to the next instruction. The stack pointer likewise will also just output to the address bus, since that's also just a pointer to an address in the memory. The memory module, that will also, since we have a memory register that we sometimes might want to input from the, or read in from the address bus, but we also might want to output that value to the address bus. And of course the memory needs to be able to output some data to the data bus as well. For the control unit, that will be connected to the data bus as well, because that is how we will shift in or read in the instruction registers. For the general purpose registers, both A and B module, that will of course be able to read and write to the data bus. These units will also be locally connected to the ALU, much like in the SAP architecture that Ben Itter used. And the ALU will of course be able to read, or not read, but write to the address bus. Not to the address bus, to the data bus. And for our I/O, that will most likely just be able to read and write to the data bus and to the address bus as well. And maybe depending on how we want the more specialized input-output modules, we might also want to be able to have some control, or have some ability to output some control signals as well. And from the ALU, as we see here also, we need to locally connect to the control unit or control logic to be able to read some flags. So for example, if we want to have a 0 flag and a carry flag, for example, we need to be able to read this in. And I have decided now that these will probably be local connections instead of being on the control bus. And that is just to simplify the design of the signals going on the control bus. And here we can see as well that there is something missing. We don't have a clock module as in Ben Ether's build, and that is because it's hiding here. So here I've written clock and backplane, and of course these buses need to be connected somehow, and I have thought about it a whole lot, and I have decided that the clock unit will also serve as the backplane and the power delivery for the computer. And this is the basic architecture that my 8-bit computer will have. So in the next episode we will start by simply making the clock module and the backplane, or at the very least think about how the backplane might look like in order to facilitate the rest of the modules. Yeah, so I hope you are as excited as I am for this project, and will see me in the next episode.